PD, into the active 2D plot to overlay PD on the 2D plot, or create label about the PD value, or generate scatter diagram as a function of PD. In order to use this option, the input mode must be set to the second input option, which is post-processing for single DD plus PD files. In this mode, in addition to the regular menu for open dynamic data, another menu for open performance data will also be shown here. Click on this open button to bring up its menu. Select the performance data file. Click on this view button to view the list of all the PD channels. After PD input file is open, the next step is to perform regular dynamic signal analysis and generate a 2D plot. For example, let's generate the RMS of a dynamic channel. Turn on basic in M1 and RMS in M2, then start. A dynamic signal is now generated and displayed in this 2D plot. Next, left mouse click on the performance data button in M right menu to show its menu. There are several analysis options available. The first one is PD overlay. For example, we want to overlay 3 PD channels onto this RMS plot. To do so, first turn on overlay option. Then select the desired 3 PD channels here. Then click select, which will show the 3 selected PDs in this table down here. Now click start. The 3 PDs are now overlaid on the RMS plot. Another PD option is label. This figure shows a PSD with its regular label, such as channel ID and RMS value. To add PD information in the plot label, turn on label first, and in its menu, select the desired statistics such as mean value. Click start. Now the mean values within the analysis time frame of the 3 selected PDs will be shown in the PSD plot label. The next PD option is 2D scatter diagram, which will plot the current dynamic signal in the 2D plot as function of a selected PD. For example, let's generate the 2D SD from this RMS plot as function of PD1. First select PD1. Then start. A 2D SD will pop up showing the original RMS as function of PD1. The third option is 3D scatter diagram, which will display the dynamic signal as function of 2 PD. Let's select PD1 and PD2. And click start. The resulting 3D SD now shows the RMS as function of PD1 in X-axis and PD2 in Y-axis. In this case, the RMS value is represented by the color legend bar here. To generate a true 3-dimensional SD, select the other 3D SD option. The RMS amplitude is now represented by the Z-axis. The last option is 4D scatter diagram, which will display the dynamic signal as function of 3 PDs. Let's select 3 PDs and click start. The RMS value is now represented by the color legend as function of PD1 in X-axis, PD2 in Y-axis, PD3 in Z-axis. The sampling frequency of performance data is typically much lower than the dynamic data. With such interactive analysis between dynamic data and performance data, it makes PC Signal a dual input signal analysis software.